Have you ever really stopped to think about what happens the instant you click on something online? I mean, in a split second, your request zips across oceans, bounces around continents, and comes right back. In this explainer, we're going to pull back the curtain and follow the incredible, invisible journey your data takes every single day.
So how does it work? How does one little click on your screen travel thousands of miles to a server and back, all literally in the blink of an eye? Well, we're going to follow a single, tiny piece of data on its epic adventure and uncover the magic that makes the modern internet possible.
Okay, so at the very heart of this whole operation is something called the network layer. The best way to think about it is like the internet's own giant, super efficient postal service, or maybe mission control. It really only has two main jobs, but they are absolutely critical: addressing and routing. So, the network layer is all about getting your digital mail, these things called data packets, to the right address, using the best route it can find. You know, just like the real post office, it has to know where a letter is from, where it's going, and the most efficient way to get it there. Right, so for any package to get delivered, what's the first thing it needs? An address, of course. The internet is exactly the same. Every single device that connects to it, your phone, your laptop, even your smart toaster, needs its own unique digital address to be part of the network.
And this is where the famous IP, or Internet Protocol, address comes into play. It's basically the unique mailing address for your device on the internet. Now, the original system that handed out all these addresses was called IPv4, and it was built on what's known as a 32-bit structure.
Using that 32-bit system, the internet could create a grand total of about 4.3 billion unique addresses. And, back when the internet was just a tiny thing for universities and researchers, that number seemed absolutely astronomical, more than we could ever possibly need.
I mean, 4.3 billion. That sounds like a ton, doesn't it? Should be enough for everyone, forever, right? Well, what the internet's brilliant founders just couldn't have predicted was the sheer, unbelievable explosion of connected devices that was just around the corner. Because today, we have somewhere around 30 billion devices connected to the internet. Laptops, phones, watches, cars, cameras, you get the idea. Suddenly, we had way more devices than available addresses under that old system. The internet was heading straight for a wall.
So, the internet is facing this massive identity crisis. Not enough addresses to go around. But hold that thought for a second. Before we get to the solution, let's look at that other critical job of our digital postal service, the routing. Once a piece of data has an address, how on earth does it navigate the insanely complex superhighway of the internet?
You see, the way the internet moves data is fundamentally different from the old way of doing things. Old telephone networks use something called circuit switching. Think of it like booking a private road from your phone to your friend's phone for your whole call. It worked, but it was super inefficient. The internet uses a much smarter method called packet switching. This is so cool. Instead of sending one big file, packet switching is like tearing a book into individual pages. You number each page, put the destination address on every single one, and mail them all separately. Your email, or that cat video you're watching, gets broken into tiny, numbered packets. Each one gets a digital stamp and is sent on its way, independently finding the fastest route at that very moment. Then, when they all arrive, they get put back together in the right order. And that right there is the absolute genius of this system. It's what makes the internet so unbelievably resilient. If one of your book pages hits a traffic jam on the information superhighway, the other pages don't just sit there and wait. Nope, they just find another way around. The packets automatically reroute around problems, creating this dynamic, self-healing network. It's brilliant. Okay, so we've seen how a packet travels on its journey. Now let's get back to that huge problem we uncovered earlier. We were literally running out of those digital addresses. To keep the internet growing, it needed a massive, fundamental upgrade.
And this wasn't just some minor technical glitch. This was a true existential threat. The internet's own runaway success had created a crisis of scarcity. If they didn't find a solution, the growth of the internet as we know it would have just stopped.
And the solution, the hero that saved the day, is called IPv6. It's the next generation of the Internet Protocol, and it was designed from the ground up to solve that address shortage and basically future-proof the internet for, well, forever.
Now, the sheer scale of this upgrade is it's hard to wrap your head around. IPv4 used a 32-bit address. IPv6 uses a 128-bit address. So what does that even mean? Well, think of a bit as a light switch that can be on or off. A 32-bit address is like having 32 light switches in a row, which gives you about 4.3 billion possible combinations.
A 128-bit address gives you 128 switches. Now that might not sound like a huge jump, but here's the key. Every single switch you add doubles the total number of combinations. This isn't like going from a puddle to a lake, it's like going from a puddle to all the oceans on Earth combined.
Yeah, we went from 4.3 billion addresses with IPv4 to this number. That's 340 undecillion. That is 340 with 36 zeros after it. It's a number so ridiculously vast that it's been said we could assign an IP address to every single atom on the surface of the Earth and still have addresses left over. We're not going to run out, ever. But IPv6 is so much more than just a bigger number. It's a fundamental upgrade to the Internet's engine. Security isn't an afterthought anymore. It's baked right into the core. It processes data more efficiently, and maybe most importantly, it's the foundation for our connected future. Every smart device, every connected car, every crazy gadget we can dream up is gonna need an address. IPv6 is what makes the Internet of Things possible on a truly global scale.
So there you have it. From a single click to a globe-spanning network that can heal itself, we've followed the journey. We've seen how the Internet's digital postal service gives every device a unique home and cleverly routes our data through a maze of connections. And by solving its own address crisis, the Internet basically unlocked a future where anything and everything can be connected. Which really just leaves you with one final thought. With a near infinite number of digital addresses, what's next for our connected world?